Well, we've talked about growth curves. Now we're going to talk about decay curves. So they're doing it in a little different way for us. If you have a negative exponent, remember this, negative exponent will be a decay curve if A is greater than 1. Okay, that's key here, because in this example, 2 with that negative exponent means I have 1/2 for a base. I personally like using the fractions for the base, but it doesn't always work that way. So what are decay curves? We have things of cooling of a cup of coffee or tea, radioactive decay, the drop in current when an electrical appliance is turned off. Now, what's key here is there's always going to be a little bit of a current flowing. It's just going to be really small. The radioactive material never totally disappears, and temperature never actually gets to the point where it freezes when you're dealing with a cup of tea or coffee. In actuality, there's a little bit different stuff in there where you're actually only going to go to room temperature. Now, current I flowing through the electric circuit in a fan T milliseconds after it is switched off is given by this equation in milliamps. So I is in milliamps and T is milliseconds. Find the initial current in the circuit. So what does this mean? T equals 0. Hopefully I'm not going to, as I've already said, I hope I don't make the mistakes I made last time. So I equals 320 times 2 to the power 0. I'm going to make that quick because negative 0.5 times 0 is 0. So our initial current is going to be 220 milliamps. Now we're going to do 4, 10, and 20 milliseconds. 4, T equals 4, T equals 10, T equals 20. So I equals 320 times 2 to the negative 0.5 times 4, which is 320 times 2 to the negative 2, 320 1/4, which is 320 divided by 4. I think, if I still have a brain left, is 80 milliamps. And yes, it is. 80 milliamps. Now, T equals 10. I equals 320 times 2 negative 0.5 times 10. So that's just 320 times 2 to the negative 5, which equals 320 times 1/32, which is 10 milliamps. This is working out pretty nice and simple. I equals 320 times 2 to the power negative 0.5 times 20. So that is 320 times 2 to the negative 10, which is 320 times 2 not times 2 times 1/1024 equals 320 over 1024. And because you guys love the calculator, I do 2. That's 320 divided by 1024. Enter. ugly number, so we're going to go math frac 5/16. I like that number a little better. Equals 5/16 milliamps. Now, I'm guessing part C is going to ask us to sketch a curve. 320, 80, 10. Move the graph up a bit. Fits a little better. So at t equals 0. So this is I, this is t. At 0, we have 320. At 4, we have 80. At 10, no, sorry. At 10, we have 10, yeah. And then at 20, we have 5/16, which is a little less than a third. Yeah. So it's a really small number over here comparatively, somewhere around there. So you sketch that curve, and we get this, our wonderful decay curve. It's a really ugly decay curve, but what's going to happen is it's going to keep getting smaller and smaller. Never touch 0 because it's my horizontal asymptote.